Imagine two cars reached the same destination. One took a straight highway. The other took a zigzag road. Both traveled 60 kilometers in 1 hour. Are their motions the same? Let's find out today. Welcome to Module 4, Speed and Velocity Concepts. Today we will cover A. Speed and average speed. B. Uniform and non-uniform speed. C. Velocity and average velocity. D. Speed versus velocity. What is speed? Speed tells us how fast an object is moving. Speed is the distance traveled per unit time. Its SI unit is meter per second. And common unit is kilometer per hour. Note, speed is a scalar quantity, this means it has magnitude only. The speed can be zero or positive. In real life, vehicles do not move at constant speed. You slow down, you speed up, you stop at traffic signals. So we use average speed. Average speed is a measure of the total distance traveled in a given period of time. Let's do some numerical practice on speed. A car travels 120 km in 3 hours. Find its speed. Total distance covered is 120 km. Total time taken is 3 hours. So, speed of the car is 40 km per second. A boy runs 400 meters in 50 seconds. Find speed. Total distance covered is 400 meters. Total time taken is 50 seconds. So speed of the boy is 8 meters per second. A man is going to his office. He covered 30 km at 60 km per hour in 1 hour and then covered another 30 km at 30 km per hour in 30 minutes. What is his average speed? Total distance covered is 60 km. Time for first 30 km is 1 hour. Time for second 30 km is 0.5 hour. Total time to cover 60 km is 1.5 hour. Putting values in the formula, the average speed of the man is 40 km per hour. Now let us move to the types of speed. Speed can mainly be divided into two types, uniform speed and non-uniform speed. First, let's understand uniform speed. A body is said to have uniform speed when it travels equal distances in equal intervals of time. For example, imagine a car traveling 1 km every minute. If the car covers 1 km in the first minute, 1 km in the second minute, and 1 km in the third minute, the speed remains constant. This is called uniform speed. Now let's understand non-uniform speed. A body is said to have non-uniform speed when it covers unequal distances in equal intervals of time. For example, a car may travel 1 km in the first minute, 0.8 km in the second minute, and 0.6 km in the third minute. Since the distance covered each minute is different, the speed is changing. This is called non-uniform speed. In real life, most objects around us move with non-uniform speed. That is why scientists often use the concept of average speed to describe motion. Velocity can be defined as the distance traveled by a body in unit time in a given direction. In simpler words, velocity is speed with direction. This means that when we talk about velocity, we must mention both how fast an object is moving and in which direction it is moving. Velocity is calculated using displacement divided by time. Mathematically, velocity is given by the formula, v equals to s divided by t, where v represents velocity and s represents displacement. For example, if a car is moving at 25 meters per second, we only know the speed. But if we say the car is moving at 25 meters per second towards the east, now we are describing velocity. There are mainly two types of velocity, uniform velocity, non-uniform velocity. Now let's understand them one by one. When a body covers equal displacement in equal intervals of time, its velocity is said to be uniform. Let's understand this with an example. Imagine a car moving. In the first 1 minute it covers 1 kilometer. In the next 1 minute again 1 kilometer. In the next 1 minute again 1 kilometer. Every minute, the displacement is the same. That means the velocity is constant. So this is called uniform velocity. Point to note, uniform velocity means both speed and direction remain constant. Now what if, in the first minute the car covers 1 kilometer? In the second minute it covers 0.8 kilometers. In the third minute it covers 0.6 kilometers. Now the displacement is changing. This means velocity is changing. So this is called non-uniform velocity. And remember, in real life, most objects move with non-uniform velocity because either their speed changes, or their direction changes, or both change. Point to remember, velocity can change in two ways: by changing magnitude, speed increases or decreases. By changing direction, even if speed remains same. Now let's move to average velocity. In real life, vehicles don't move at constant velocity. Their speed keeps changing. So how do we measure overall velocity? We use average velocity. Average velocity is the total displacement divided by total time taken. Imagine you travel from home to school. During the journey, sometimes the car moves fast. Sometimes it slows down. Sometimes it stops. The speedometer shows different readings at different times. But if someone asks, what was your average velocity for the entire trip? We calculate total displacement from home to school, divided by total time taken. That gives us the average velocity. If velocity changes at a uniform rate, that means motion is uniformly accelerated. Then average velocity can be calculated using average velocity equals to initial velocity plus final velocity divided by 2. Now comes the most important and most confusing part for students: speed versus velocity. Let's clear this once and for all. Speed is the distance covered per unit time. Formula is speed equals distance divided by time. It is a scalar quantity. It can never be negative. Velocity is the displacement covered per unit time. Formula is velocity equals displacement divided by time. It is a vector quantity. It can be positive or negative. Now we are going to solve a very important Hotz numerical for motion. A cyclist moves 30 meters towards east with a speed of 10 meters per second. Then moves 40 meters towards north with a speed of 20 meters per second. We need to calculate A. Average speed, B. Average velocity for the whole journey. Let's first calculate average speed. Now we solve step by step. Step 1. Find time for first part, A to B. We know, distance equals 30 meter. Speed equals 10 meters per second. Using formula, speed equals distance divided by time. So, time equals distance by speed. Time equals 30 by 10. Time equals 3 seconds. Step 2, find time for second part, B to C. Distance equals 40 m, speed equals 20 meters per second. Using the same formula. Time equals 40 by 20. Time equals 2 seconds. Step 3, find total distance and total time. Total distance equals 30 plus 40 is equal to 70 meters. Total time equals 3 plus 2 is equal to 5 seconds. Step 4, calculate average speed. Average speed equals total distance divided by total time. 70 by 5. Average speed is 14 meters per second. I have shown two ways to calculate average speed of the cyclist, feel free to either of the ways. Now comes the interesting part, average velocity. Be careful here. Velocity is based on displacement, not distance. So we cannot simply add 30 plus 40. Step 1, find displacement. The cyclist moved 30 m east and then 40 m north. This forms a right-angled triangle. So we use Pythagoras theorem. So total displacement equals 50 m. Step 2, use average velocity formula. Average velocity equals displacement divided by total time. We already calculated total time equals 5 seconds. So, average velocity equals 50 by 5 is equal to 10 m/s. Step 3, direction. Now velocity must have direction. Since motion was towards east and then north, the final direction is northeast. And with this, we complete today's module on motion. In our next module, we will dive deeper into acceleration, where you'll learn about what acceleration really means. Uniform and non-uniform acceleration. Positive and negative acceleration. And how to understand motion using graphs. These concepts are extremely important for numericals and board exams, so make sure you don't miss the next lesson. If you found today's session helpful, like the video, share it with your friends, and subscribe to stay updated. See you in the next module. Let's keep learning and